Hello everyone, welcome to Mpumalanga's Maths and Science YouTube channel. And today we're looking at the Mpumalanga Maths Paper 1, September 2016 trial exam for grade 12. And our focus today is on question 3, which is functions. Now, in these functions, there are 3 different types of functions. 1, g of x, which is equal to negative 2x plus 8, and it's a straight line, with f of x is equal to x squared plus c, which is a quadratic function, and h of x, which is equal to negative 6 over x minus 2 plus 1, which is a hyperbole. And the point A and B are the x and y intercept of h of x, so respectively c, which is given by minus 6 is to 20, and e are the points of intersection of f and g. Now, they want us to calculate the coordinates of A, B, and E. Now, A is the x-intercept of both graph of f and graph of h. And B is the y-intercept of graph of h. Then E is the other part of the x-intercept of the graph of f and the graph of g. So, if we want the coordinates, we have to start in 3.1 to say we want the coordinates A, B, and E, right? Now, we said that A is the x-intercept of h of x. Now, h of x is given by which function? The hyperbole. And the hyperbole being 6 over x minus 2 plus 1. Now, if we look at the x-int, we let y be equal to 0. Now, when we say y is equal to 0, this means that y is equal to 6 over x minus 2 plus 1. Then we make this one to be equal to 0, and we solve for x. So x minus 2 plus 1 and minus 1 is equal to 6 over x minus 2. Then we can say we can cross multiply to get a minus x plus 2 is equal to positive 6, such that this is, if you take the 6 to the 6 to the left hand side and the negative x to the right hand side, this becomes a negative 6 plus 2 is equal to x, and x will be equal to negative 4. That is the coordinate A, which is minus 4 is to 0. And if we can check here within this graph, it's on the left side of the x-axis, so it's definitely a negative. Then for B, we can see B here, that it's the where the graph of h of x cuts the y-axis, so that is the y-intercept. For y-intercept, or for B is the y-intercept of h. So for y-int, we let x be equal to 0, so that if y is equals to 6 over x minus 2 plus 1, and y will be equal to 0 minus 2 plus 1, and this is equal to a negative 3 plus 1, which is equals to negative 2. Therefore, B is the coordinate 0 is to negative 2. Now we look at E. E is where both G and F, but we cannot use F because F has an unknown, so it won't be easy for us. So let's go for G. G is the graph which is a straight line, and at E the graph of G cuts the x-axis, so it's an x-intercept, meaning the point E is the x-intercept of g of x, whereby g of x is given by minus 2x plus 8. Now x int, we let y be equal to 0, which means from y is equals to negative 2x plus 8, 0 is equals to negative 2x plus 8. Take negative 2x to the other side, becomes a 2x is equals to an 8. Then we divide both sides by 2, and x is equals to positive 4. Therefore, E is a 4:0. Right. Second question, 3.2. Show that the value of C is equal to 16. Where is C? Now C is here. This is C, and C is the constant, which means this is where the graph cuts the y-axis, which means C is the value here where the graph cuts the y-axis. Okay. Right, now let's go back. The graph of f in 3.1.2, the graph of f of x is given by x squared plus c. But we've already got a point, which is the point E, which we can use to test, and the point A. So we can either use point A or point E. So I just choose point E to use in the function. So point E is a 4:0, which means 0 is equal to x squared. Oh well, not x squared plus 0 is equal to 4 squared plus c. Now 0 is equal to 16 plus c, and c is equals to negative 16. Then we move to 3.3. Write down the values of x for which g of x minus f of x is greater or equal to 0. I decided to make this one a little bit longer. We now have g of x and f of x, but g of x is greater when you subtract the value. Okay, let's have a look at this. 3.3. We have f of x, which is now equal to an x squared minus 16, and we have g of x, which is equal to a negative 2x plus 8. So if we have g of x minus f of x being greater or equal to 0, This means the function itself, which is given by minus 2x plus 8, subtracts this function of g of x, which is x squared minus 16 greater or equal to 0. So this is more of a quadratic inequality, which goes to becoming negative 2x plus 8 minus x squared plus 16 greater or equal to 0. Then if we simplify, it becomes a minus x squared minus 2x, and 8 plus 16 becomes a positive 24 greater or equal to 0. Then if we can divide throughout by negative 1, that leaves us with the sign of the inequality changing to becoming a less than or equal to 0. So we will have now x squared plus 2x minus 24. Now, the factors of 24 that can give us a 2 are 6 and 4. But how can a 6 and 4 give us a positive 2 when this one is positive and this one is negative? Which means we can open two brackets, less than or equal to 0, put x and x, then we put our positive 6 and our negative 4, so that we can get our critical values, like in the previous video that we did for question 1. Critical values this is where we can say or solve just like as we would solve a simple equation with equal to 0. So at this point we will say x plus 6 is equal to 0, or x minus 4 is equal to 0, so that x is equal to minus 6 or x is equal to 4. We're not yet done, because we can either do the graph and put minus 6 here, positive 4 here, or we can use the number line system. And it says less than or equal to, so we're going to draw two circles here, shade them, and we join. Or we draw and then we shade in between, because this is where we find the function less than. And we are not yet done, as we're looking for which values of x. The values of x are found in between what? Minus 6 less than or equal to x less than or equal to 4. And then for 3.4, determine the equation of the symmetry axis of h if the gradient is negative. Now, a hyperbole will have an axis of symmetry, as you can see here. A hyperbole will have an axis of symmetry that goes right through this point, whereby this part can be reflected to this part. Okay, I'm gonna erase that. Okay. So, determine the equation of the symmetry axis of H. For you to find the symmetry of axis, you first need to find the asymptotes, because that is where that axis of symmetry line passes through. So in 3.4, we are looking at y is equal to 6 over x minus 2 plus 1. First, Your x asymptote is given by x minus 2 is equal to 0. Then you solve for x is equals to positive 2. And your y asymptote, we always say y is equals to a q from y is equals to a over x minus p plus a q. Therefore, y is equals to positive 1. And this means that you have the coordinate at the intersection of the two asymptotes being 2 is to 1. And they say that it has a gradient that is negative. So it's always a positive 1 or a negative 1. Meaning, if you have a hyperbole in here, this axis of symmetry line will have a gradient equal to a negative 1. But if you have a hyperbole like this will have a gradient that is equal to positive 1. I hope it makes sense to those that will not understand. I'll do more videos explaining on hyperbole. Right. Now, the gradient is equal to negative 1. So, we can use our analytical skills here by using y minus y1 equals to mx minus x1, being x1 and y1. So y minus 1 is equals to negative 1x minus 2. Then this becomes a y minus 1 equals to negative x plus 2. Y minus 1, not y minus 1, y is equals to positive 1 minus x plus 2. And this is equals to minus x plus 3. And that is your equation of the axis of symmetry of H. Now in 3.5, they're looking for, show that the length of BE. Now the length of BE comes from this to this E, right? So we've already got the coordinates of B and the coordinates of E, so that shouldn't be a problem. BE. Now the coordinates of, first it's number 3.5. Coordinates of B are 0 is to negative 2, and the coordinates of E are 4 is to 0. So we can label and say x1, y1, x2, y2. We want to show that the length of BE is equal to 2 root of 5. So BE can be given by, also we can borrow from our knowledge of analytical geometry, that x2 minus x1 squared plus y2 minus y1 squared. Then we substitute our x2 being 4 minus 0 squared plus 0 minus negative 2 squared. Then this becomes a 16 plus 4 is equals to square root of 20, which is equals to 2 root of 5. And that is true. 3.6, they say, what is the range? The range, or write down not what is. Write down the range of S if S of x is equal to h of x plus a 2. Okay, 3.6. Now we want S of x, which is given by h of x plus a 2. Now, what is h of x? H of x is 6 all over x minus 2 plus 1. Now if we add a 2 to it, this then becomes what? 6 over x minus 2 plus 3, which means the value of q has increased to what? To a 3. Therefore, the range is still y is an element of all real numbers, but y cannot be equal to 3 because now 3 will be the asymptote. Last question. The last question is, if t is a tangent to f and parallel to g, determine the equation of the tangent t in the form y is equal to mx plus c. So if you are a grade 12 learner, you already know a few things about having a tangent. From calculus. Now, f of x, first it's 3.7, f of x is equal to what? 3 is equals to x squared minus 16, and from the knowledge of calculus, you know that f prime of x gives you, or is equal to the gradient of the tangent, which they said the tangent of, and in that tangent is parallel to g, which means the gradient of the tangent is also equal to the gradient of g. But we already know that the gradient of g is what? Is given by minus 2. But then let us check what is our value of f prime of x. F prime of x is what? Is 2 times 1 x to the power of 2 minus 1, and which gives us a 2x. Now this means that if the gradient of graph of g of x is equals to negative 2, those two are the same thing, meaning 2x is equal to a negative 2. And if we divide both sides by 2, we get that x is equals to negative 1. This negative 1 needs to have its counterpoint, and you can only get the counterpoint from what? From the original function, which is f of x is equals to x squared minus 16. So f of negative 1 is given by minus 1 squared minus 16, which is equals to 1 minus 16, and it's equals to negative 15. So this means the coordinate whereby the graph has a tangent is minus 1 is to minus 15. We are looking for the equation of that tangent, and they say it has the same gradient as the graph of g. Now the graph of g has a gradient which is equals to negative 2. Therefore we can use y minus y1 equals mx minus x1, which means you can simply substitute y minus negative 1 is equal to negative 2 into x minus negative 1. Well, we can simplify that into a y plus 1 is equals to minus 2 into x plus 1. Then y plus 1 is equal to negative 2x minus 2. And y is equals to negative 2x minus 2 minus 1, which is equals to minus 2x minus 3. Oh, shit. I made a minor mistake here. Right. It's not a minus 1 substitution. So I'll have to erase here. Oh, beautiful people, I also do make mistakes. Okay, this is a minus 15 minus 1 5, so it becomes a positive 1 5 and a positive 1 5 and then negative 1 5 to become a negative 17. There you go. Our tangent t of x will be given by minus 2x minus 17. Right, thank you for watching. And I forgot to mention in the beginning that this video is relevant for grade 11 and I think grade 10 learners. Yeah, it's quite a video for grade 10, 11 and 12, which was written in grade 12. So yeah, thank you for watching. Please like, share and subscribe. See you soon.